Welcome you all for the next session on classification techniques using decision tree and random forest, which will be handled by Dr. S. Balakrishnan. I feel glad in introducing our resource person to the gathering. Dr. S. Balakrishnan is a professor and head Department of Computer Science and Business System at Sri Krishna College of Engineering and Technology, Coimbatore. She has 19 years of experience in teaching, research, and administration. He has published over 20 books, 8 book chapters, 29 technical articles in CSA Communications magazine, 27 technical blogs, 1 article in Electronics for You magazine, 9 articles in Open Source for You magazine, and over 100 plus publications in highly cited journals and conferences. Some of his professional awards include International Data Science Writer of the Year 2021 by Data Science Foundation UK MTC Global Outstanding Researcher Award, Inspiring Authors of India, Deloitte Innovation Award, Patent Published Award. His research interests are artificial intelligence, cloud computing, and IoT. He has published 5 granted Australian patents, 33 Indian patents on IoT applications, 3 design patent grant, and 2 granted copyright. Dr. Balakrishnan has been appreciated under India Book of Records 2021 for filing 8 patents over a period of 15 months. He is acting as IEEE Brand Ambassador, T4 Ambassador, and Bentham Science Publisher Brand Ambassador. I would like to request our resource person, Dr. S. Balakrishnan, to take over the session.
Yeah, good morning to everyone. Thank you so much for your nice introduction, ma'am. So it gives me a great pleasure for me to extend my wishes to all the participants. So can I share my screen?
Yes, sir, you can share your screen.
Screen is visible, ma'am?
No, sir. Your screen is not visible to us, sir.
What about now?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Visible to us.
Okay. So can I proceed? Yeah, actually, once again, very good morning to one and all present here. So the today topic is classification technique. Very particularly, it's focusing on the decision tree and random forest algorithm. So before that, the classification is nothing but it's a process of recognizing, understanding, and grouping some ideas and object into the present categories, or we may say some populations. So using some kind of pre-categorized training data sets, that machine learning machine learning programs use a variety of algorithms to classify the future data sets into categories. So that's why the classification algorithm in machine learning that use the input training data to predict their likelihood that subsequent data will fall into one of the predetermined categories. That's a very important. That's why we go for the classification. So one of the most common uses of classification is like filtering the email. That is filtering of the email into spam and non-spam. So like that, that's one important real-time application. And in short, that classification is a form of, we may say it's a kind of pattern recognition with the classification algorithm that apply to the training data to find the same problem, like similar words or sentiment, some kind of sentiments or number sequences, etc. So in future sets of data, that is a very important thing. That's why using this classification algorithm. Actually, we will go into that detail about in the upcoming next one and a half hours. We are going to discuss elaborately how that decision tree and random forest algorithm will be very useful, and what are the cases why actually so many classification algorithm or classification techniques are there. But apart from that classification, all other techniques, this decision tree and random forest is somewhat a very useful and a very better way of in some real-time applications. So we will discuss in the next 1.5 hours. So that's why whenever we go for that doing such kind of that classification, here the very important thing we may say the text analysis software that can perform the task like aspect based sentiment analysis, that will be to categorize the unstructured text by topic and the polarity of that opinion, either the positive, negative, neutral, and beyond like that. So based on this introduction, just I start my session. So the overview of today's session is start with like that, just introduction about the different types of classification and what are the types of classification algorithms are there, and from which we are choosing two algorithms, very particularly that decision tree and random forest. And after that, simple analogy to explain the decision tree versus random forest in some real-time scenario, how that this two algorithm will be very useful. And next, brief introduction about the decision tree and overview of the random forest algorithm and what are the classes between the random forest and decision tree, and why it is the random forest algorithm is somewhat it's outperforming a decision tree. And the next thing, a decision tree versus random forest, and when should we use actually which kind of algorithm. So if suppose if you go for doing the research, that will be very useful, and what kind of application and in what way in that decision tree or random forest will be using, and finally conclude with that the different application advantage and disadvantage. That is the final thing. So this is the overview of today's session, and the first we'll start with that introduction. See, whenever we were talking about that classifications, already I told you the classification mainly it's a structured data classification. One very important thing is a structured and unstructured. But here the classification can be performed on both structured or unstructured data. That's why the classification is a technique where we categorize the data into a given number of classes. So the main goal of this classification problem is to identify the category or the different classes to which a new data will fall under, that which category or which kind of things. That's the thing. And actually here we are going to see that a few of the terminologies that you encounter whenever you go for seeing such kind of classification. That's a very important thing. The first keyword is a classifier. The classifier is nothing but an algorithm that maps the input data to a specific category. That's very important. That's the first. The classifier is nothing but it's an algorithm that maps the input data into a specific category. And second keyword is a classification model. So the classification model mainly tries to draw some conclusion from the input value that given for the training, and also it will predict the class labels or categories for the new data. That's very important in that classification model. And third keyword is a feature. So again, the feature is an individual measurable property of a phenomenon that being observed whenever we going for taking such kind. In that feature also very important. And fourth category is a one keyword is that binary classification keyword. So that is that classification task with the two possible outcome, either 0 or 1 or true or false like that. Suppose for example in the gender classification, either category is male or female. That's it's a binary classification. But nowadays we are having male, female, or not classified like that. That is also there. But earlier days it's classified as a binary classification like that. And second thing is a multi-class classification. We know that in that multi-class classification that with more than two classes. So in multi-class classification, each sample that is assigned to one and only one target label. Say the example is suppose in that animal can be any category. It may be a cat or it may be a dog, but not both at the same time. So that's the thing. Even actually we are having the multi-label, but even though the output is target label is only one only, that is the thing. The animal, either the cat or dog, but not both at the same time like that. So that's a category, that's a multi-class classification. And another very important thing, multi-label classification. In that multi-label classification, it's nothing but here the classification task where each sample is mapped into a set of target label. The target label may be more than one class. That example, we may say that the news article can be about the sports, a person, or the location at the same time. So this is about the more than one classes are there. So any kind of the news are related to any kind of sports or any kind of person or location at the same time like that. So that is a very important thing. That is a multi-label classification. So these are some of the keyword whenever we go for doing such kind of that classification. These are the things we are using it. And another very important thing, And the following the some of the that steps, some steps to be involved in building a classification model. So based on these 6 parameters, 6 keywords, some of the things or some of the steps to be involved while building a classification model. The 4 steps to be needed. First, we have to initialize the model. That is, initialize the classifier to be used. Second thing, we have to train the classifier. That's a very important thing. So all the classifiers based on that skit, that is what is a skit, that SAE kit, that skit learn, that uses the fitting of the X and Y, that we will see it in the upcoming demo part. That is train the classifier. And third important step is we have to predict the target, which one is our output, which one is predicted output. So that's a very important thing. And finally, evaluate the classifier model. So these 4 steps to be involved while doing such kind of classification model. And apart from that, the data set sources and content is also very important. So whenever go for any kind of data set, the data sets having different classes or different attribute and different instances. That is, a different instance is nothing but different rows. The classes may be based on that we may use a binary class or multi-class or multi-label class, like that. So that's a very important thing. So whenever we are focusing about the data set sources and content, these 3 parameters, these 3 descriptions is very important of the classes, of the attribute and the instances. So these 3 things is very, very important thing. So that is the overview, that is the introduction about the data classification. And the next thing is the what are the different types of classification algorithm. So first we'll see about the different kind of algorithm. Then based on just we'll go with that different kind of algorithm. Then after that we'll go with very particularly the decision tree and the random forest algorithm. And we are having some 6-7 types of algorithm. So the first one is a logistic regression, and second algorithm is a naive Bayes algorithm, and third one is a stochastic the gradient descent algorithm, and fourth one is the k nearest neighbor algorithm. Fifth one is a decision tree, and sixth one is a random forest and support vector machine. So these are some of the 7, we may say the top 7 classification algorithm. So based on that application, it can be varied. So these are the 7 and kind of classification algorithms. Start with the logistic regression, naive Bayes algorithm, stochastic gradient descent algorithm, k nearest neighbor. The decision tree and random forest is our focused algorithm. That is a next finally support vector machine. So we will see one by one. So the first algorithm is the logistic regression. So the definition of the logistic regression, we know actually the logistic regression is a machine learning algorithm for classification. And in this algorithm, the probabilities that describing the possible outcome of a single trial or the model using a logistic function. So that's a very important idea or prime point behind this logistic regression. That is that possible outcome of a single trial or a model using a logistic function. That is a very important. An advantage of this logistic regression is this is mainly designed for the purpose of the classification, and it's the most useful for understanding the influence of several independent variables on a single outcome variable. That's a very important. If suppose you go for any kind of research application, that is a mainly this logistic regression is influencing of the several independent variable on a single outcome variable. That's a main advantage, and the disadvantage is this algorithm works only the predicted variable is binary. That is the only drawback, and it assumes all the predictors are the independent of each other, and assumes that the data is free of some missing value. So that is also some disadvantages. And the coding, maybe the Python coding for this logistic regression, this is very easy to make it. So this is this we have to import the logistic regression from that scikit library function. So based on that, we are doing the logistic regression and the fitting and the training the things. We are doing the training and predicting the cases. So this is a logistic regression. Second model is the second classification algorithm is the naive Bayes algorithm, and the main definition of that naive Bayes algorithm is it's mainly based on the Bayes theorem. We know the Bayes theorem is nothing but it's the assumption of the independence between the every pair of the features. And in this naive that Bayes classifier algorithm will work well in many real world situations, such as document classification. Even already I told you that spam filtering, that email spam filtering, either the spam mail or non-spam. So in that cases also this naive algorithm is very very important. So this is the thing, and advantages of naive algorithm is it's a this algorithm requires a small amount of training data to estimate the necessary parameters. That's a very important thing. That's a very important advantage, and also it's extremely fast compared to the more other sophisticated methods. That's advantage. That's why this naive algorithm is mainly used in that this spam filtering. And next, the disadvantages is sometimes this algorithm is known to be a bad estimator. So that is one drawback. And the coding of this naive algorithm is like that. So import the Gaussian naive Bayes algorithm. Just we are training things like that. And the third algorithm is the stochastic gradient descent algorithm. So the based on the stochastic gradient descent algorithm, the definition is this algorithm is a very simple and a very efficient algorithm, and for mainly for fitting the linear model. That's very important, and very particularly this algorithm will be useful when the number of sample is very large. That's a very important, and also this algorithm support different loss function and penalties for the classification. That's also happening, and the advantages is efficiency and ease of implementation. So somewhat it's an efficient one and easily implement. This algorithm will be easily implemented. That's the main advantages. And the disadvantages is it requires a number of hyperparameter and it is very sensitive to feature scaling. So that is a drawback of this algorithm. And the coding for this one, this is also the same as actually it's based on the SGD classifier. Just we have to import the SGD classifier, that is a stochastic gradient descent classifier, that is available from this Spit library. That is from that we are making it. Okay. So this is the third algorithm, and fourth algorithm is the k nearest neighbor algorithm. And the k nearest neighbor algorithm, it's mainly this algorithm is a type of we may say it's a lazy learning, but it does not attempt to construct a general internal model, but simply store the instances of the training data. That's why it's a k nearest neighbor everything. But in this algorithm here, the classification is computed from a simple majority vote of the k nearest neighbor of each point. That's mainly happening in that k nearest neighbor algorithm. And the advantage is this algorithm is very simple to implement, and at the same time it's robust to noisy training data and also effective if the training data is very large. So that's a very important advantage. And the disadvantage is this algorithm is need to determine the value of k. That's a very important. See, the value of k should be that determined, and the computation cost is somewhat high. That based on that k value, as it needs to compute the distance of each instance to all the training samples. So that's the one drawback of this algorithm. But even though this algorithm is somewhat easy to implement, and also very that robust to noisy training data, and even this algorithm is somewhat effective for large data sets. So that's a very important thing. So the Python coding here, all the way we have to import the k-neighbors classifier algorithm, that package. So based on that package, here we are all the way we are doing. So here the k value is given as 50 like that. So that is the thing. So that's happening. And next algorithm is the decision tree algorithm. Whenever we are talking about the decision tree algorithm, mainly here, this, suppose if you are given a data of attribute that together with its classes, this decision tree that produces a sequence of rules that can be used to classify the data. So that will elaborately discuss in the upcoming topics. But before that, just I will repeat the definition. Whenever we are focusing that a given set of data of attribute together with its classes, this decision tree produces a sequence of rules that can be used to classify the data. So that's why it's a decision tree. We are all the way we are making the decisions in the tree format, the tree manner. So based on that decisions only, based on that rule, all the way we are producing, all the way we are providing the rule Based on that rule only, the classification of the data is happening. So that's why this is called as a decision tree. So the main advantage of this algorithm is somewhat simple to understand and also visualize that is happening, and it requires a little data preparation, and also it can handle the both numerical and any kind of categorical data. That's a very important idea behind this decision tree. That's why all the way it will be very useful, and at the same time it is having some drawback. So the disadvantage is this algorithm, this decision tree can create a complex tree that do not generalize well, and the decision tree can be unstable because some small variation in the data might result in a completely different tree being generated. So this is the coding. So the coding is here. We are importing the decision tree classifier. So based on that, we have to here in that in a decision tree classifier, we have to give the depth and random state, the features, and the sample rate is 15 like that. So this is the coding for the decision tree. And next algorithm is a random forest algorithm. So that is also we are focusing. So as per the random forest algorithm, this classifier, this algorithm is a meta estimator algorithm that fits a number of decision trees on various subsamples of data sets and uses and also this algorithm uses average to improve the predictive accuracy, the predictive accuracy of the model, and also the very important, it controls the overfitting. That's a very important concept. See, yeah, that is the overfitting is very important in the what the parameters should be considered while doing such kind of classification. That's why this as per this random forest algorithm, it controls the overfitting also. And another important thing, we are using the sample. Here the subsample size is always the same as the original input sample size, but the samples are drawn with the replacement. So that is a main idea behind this random forest. And advantage is here the reduction in overfitting, and the random forest classifier is more accurate than the decision tree in most of the cases. That's the thing. That's why the random forest algorithm is a somewhat accurate one compared to decision tree algorithm. And the disadvantage, this algorithm sometimes it's a slow real-time prediction, and sometimes it's difficult to implement, and also this algorithm is somewhat complex algorithm. So the Python coding for this random forest is here we have to import the random forest classifier. So based on that, here we have to provide the estimator and score value and the random state and features and leaf values, everything we have to use. Even based on that, the random forest algorithm is working. And the final algorithm, the final classification algorithm is the subcode vector machine. So the subcode vector machine is a representation of the training data as points. The way because it's supporting something in space separated into categories by a clear gap that is as wide as possible, like that. So that's why this is a very important. So here, whenever we are using the new example, that new examples are mapped into that same space and predicted to belong to a category belongs to the category that is based on which side of the gap they say fall, like that. So that is mainly that point mainly to be considered in that support vector machine. And the advantage is effective in high dimensional spaces and uses a subset of training points in the decision function. So it are also the memory efficient. That's the advantage. And disadvantage is that algorithm does not directly provide any kind of probability estimates. So these are the calculated using an expensive validation. That is, we may say 5-fold cross validation. So based on that only performing, and the coding for Python coding for the SVM is we have to import the SVC, that is SVC library, that is the Python library. And based on that, here we have all the way we are doing the kernel in the linear format, and we have to give the random state, and the C value will be given. So that is the very important thing. And next point, actually, this is our thing. Actually, what is a simple analogy to explain the decision tree versus random forest? And let's just start with the thought of some experiment that will illustrate the differences between the decision tree and the random forest algorithm. Suppose, just take this scenario, this analogy. Suppose a bank has to approve a small loan amount for a customer, and the bank needs to make a decision somewhat quickly. So in that cases, the bank check the person's credit history and their financial condition, and also it finds that they have not repaid any loan, any older loan, not yet or like that. In that cases, that the bank reject that application, but here is the catching. Actually, the loan amount was very small for the bank's immense offers, and they would have easily approved it in a very low risk move, and therefore the bank lost the chance of making some money. So in that cases, another loan application comes in a few days down in a line, but this time the bank comes up with a different strategy. That is a multiple decision making processes. That is, sometimes it checks for the credit history first, and sometimes it checks for the customer's financial conditions and loan amount first, like that. So here it's happening. This the priority, or which one is important, which one should be checked first, that will be changing. So then the bank combine these results from these multiple decision making processes and decide to give the loan to the customer. In that cases, if this process took more time than the previous one, the bank profited using this method. In that case, this algorithm will be very useful. So that's why this example is a random forest or a decision tree. So this is a classic this example where the collective decision making that outperformed a single decision making process. So that is the thing. In that case, here the decisions, here the two decisions are there, either random forest or decision tree, and we will explore this idea in somewhat detailed manner in the upcoming slide, and also what are the major differences between these two methods, and what are the which algorithm or which one is better compared to these two. So everything we'll discuss in the upcoming slide. So that is a simple analogy. At present, actually, in the banking domain, these two algorithm is very useful for providing such kind of loan approving the loan and other things. So that will be the simple analogy, the real-time scenario. So next, the brief introduction about that decision tree algorithm. So here, already we know the decision tree algorithm is a supervised learning algorithm, and that can be used for both the classification as well as the regression problems. So that's a very important. So that's why the decision tree is simply a series of sequential decision that made to reach a specific result. So here is an illustration of the decision tree in that example. See the diagram. Here the decision tree for the loan approval. Already we have, in the previous slide we have seen about the that analogy for loan application. So one analogy based on that decision tree and the random forest, very particularly in the banking domain. So in that cases, this here the credit history. If it's a good, in the sense we have to either it's a good or bad, we go with the income. If the income, next we go with the income. Income with a high, in the sense we have to check the amount. Loan amount is either small or big. So in that case, if the income is high, loan amount is either small or big, we may go for approval. Suppose the loan amount is small, but income is also very low, then we'll go with the small loan amount, like that. So these are the different possibilities that's happening. So this is a thing. So as per that, first we have to check the customer has a good credit history. That's the first point. And after that, based on that, it classifies the customer into two groups. That is the customer with the good credit history and customer with the bad credit history. Then it checks the income of the customer, and again it classifies the information into two groups. That is the loan amount, and finally check the loan amount requested by the customer. And based on the outcome from that checking, these three features, the decision tree decides if the customer's loan should be approved or not. So that's why that these features or the attributes and the conditions can change based on the data and complexity of the problem, but the overall idea remains the same in all the cases. So that's why the decision tree make a series of decisions that is based on a set of attribute or features that present in the data, which in the case where the credit history, income, and loan amount. So these three parameters, these three attributes, these three features we are considering: credit history, income, and loan amount. So based on that, so now you might be wondering, that is Why did the decision tree check the credit score first and not the income? Why? Because this is known as that feature importance and the sequence of the attribute to be checked. That is based on, that is a decided, that is based on the criteria, like which one is, that is a, we are having some parameter in that classification, like information gain or GNNI, that is a Gini Impurity Index, like that. So based on that only, the credit history is checking first, then after that only we go for the income. Instead of checking income first and the credit history, next so we'll go with the credit history and income, and after that loan amount. So this is a very important, that is that priority is given. So all the way the decision will be given. So based on that only, the finally we are getting the solution. So that's a very important concept. Next thing, the overview of the random forest. So whenever the overview of the random forest here, the decision tree algorithm is somewhat quite easy to understand and interpret, but often a single tree is not sufficient for producing the effective result. So that is a very important point to be considered in the previous decision tree. That's why this is where the random forest algorithm comes into the picture. So the random forest is mainly based on the tree-based structure or tree-based algorithm that leverages the power of multiple decision tree for making the decisions. That is also based on the decision tree only. But as a name proposed, it is a forest of trees. So why do we call that random forest in the sense? That's because it's a forest of randomly created decision tree. That's a very important point. In the random forest, we are using the decision tree also. So that's why we are randomly choosing the forest of that trees node. That's why here each node in the decision tree works on a random subset of the features to calculate the output. The random forest then combines the output of individual decision tree to generate the final output. In simple word, we may say the random forest algorithm is just simply combine the output of multiple, that is the multiple in the sense it may be a randomly created a decision tree to generate the final output. So consider this example. So here the data sets are there. So the data sets with the different decision trees are there, result 1, result 2, result n, and finally we are finding the average result of all result 1 to result n. Finally we are getting the result. So that's why here all the way the decision trees are used, and here it combine the multiple output, that is a randomly created multiple output decision tree to generate the final output. That's happening. So that's why this process of combining the output of multiple individual model in the sense it's also sometimes called as the weak learner, that is called as the ensemble learning. That's a very important, that is the ensemble learning is very important in the random forest algorithm. And next, what are the classes? In what way and where that the random forest and decision tree algorithm is clashing? So in that cases, actually, I want to clarify in this section with we will be using some Python coding to solve the binary classification problem that using both the decision tree as well as the random forest algorithm, and we will then compare their result and see which one is suited our problem the best, like that. So here we will be working for the same algorithm, loan prediction data set, that from that the data hack platform that is already available. So here in that case, this is a binary classification. Yeah. Problem that we have to determine if a person should be given a loan or not based on a certain set of features. In that case, first step 1, all the way we have to loading the libraries and data sets, and step 2 we have to pre-process that data sets, and third step we have to creating the training and the test set cases, and step 4 is we have to building and evaluating the model, and that's the thing. We will see one by one. So these 4 steps to be needed. So based on this 4 process, based on this loan prediction data sets, we are going to compare which algorithm is best and why the clashes is happening, like that. So we will see based on this scenario loan prediction data sets. So here the first step 1. The step 1 is nothing but loading the libraries and data set. So here just let's start by importing the required Python library and our data sets. So it's happening here. So all the way we are importing all the library and the data sets also. So just we are reading all the data set, and after that this is a thing is happening. So here this data set contained some what are the rows. based on that, actually so many rows are there, but here 614 rows and 13 features, 13 features and 13 attributes are there, that including the credit history, their marital status, and the loan amount, and the gender category, and everything are there. But here our target variable is like the loan status, and which indicate whether the person should be given a loan or not. So the loan status is either 1 or 0 or yes or no, like that. So that is happening. That's why here, with the help of this, first we are step loading the libraries and data sets. And second step, the data pre-processing. Actually, here this now we are coming into the most crucial part of any data science project, that is the data pre-processing and feature engineering. So in this section, just I am going to deal with the categorical values in the data, and also inputting that some missing values. And also I will input that some missing values like categorical variable with the more, and for the continuous variable, that with the mean that for some what a corresponding column, which column or which attribute is needed for our output, like that. So in that case, this is a coding for that. And after seeing this, here we are getting some output. It's a load status is instead of yes or no, we are getting 1 or 0, like that. This is the previous slide. It's happening like that. Yeah. So this is the thing. As per the thing, the previous load status we are given. Yeah, the previous one before data pre-processing, it will make it made it as yes or no, y or n. But here after that, the load status is make it as a 0 or 1, like that. So that's happening. That's a and third important point is creating a train and test sets. So here normally we have used the splitting of the data sets into 70-30 ratio, like that. But here I made it a 80-20 ratio for training and test data respectively. See the first diagram. Okay, this is the 80-20 that all the way we are making that thing. And let's take a look at the shape of the created train and the data sets is based on that, the different shapes and everything, and we are making it like that. So here now we are ready to go for the next stage, where we will be build a decision tree and the random forest model. So that's the thing. And the fourth step is actually building and evaluating the model. And since we have both the training and testing sets, it's a time to train our model and classify the loan application. And first, we will train a decision tree based on the data sets. Consider this figure here. This is this we are building the decision tree. In that case, we have to import the decision tree classifier, and we are all the way we are going to train and predict the things. And next, we will evaluate this model using the F1 score. The F1 score is very important. That is, the F1 score is a harmonic mean of the precision and recall that is given by the formula. This is the formula we know. The precision in 2 into precision recall divided by precision plus recall. So based on that, that is a very important thing. So whenever we go for that, so many parameters, the evaluation metrics are there, like confusion metrics, F1 square, gain and lift chart, and log loss, root mean squared error, cross validation, and so many that evaluation metrics are there. And let's evaluate the performance of our model using the F1 square. So in that cases, after training set, the evaluation F1 square for this algorithm, that is this decision tree classifier is 1.0, and after that we go for these things. So the training set evaluation for the F1 square for this one is actually this is the 0.79, like that. So this is for the decision tree, and here you can see the decision tree perform well on in some in-sample evaluation, but its performance decreases drastically on the out of the sample evaluation. So that's why unfortunately our decision tree model is somewhat overfitting on the training data. So that will that random forest algorithm solve this issue in the sense that we are going to discuss in the next slide. The same thing we are same up to step 2, same thing. But in the step 3 and 4, we are building with the random. Instead of the decision tree algorithm, we are building with the random forest model. So let's see the random forest model in action. So here this is just we are doing the predictions and everything. And here the training set evaluation is 1.0. and after that here the testing set evaluation is 0.84. So the decision tree is 0.79, but the random forest algorithm is 0.84. So here we can clearly see that the random forest model performs much better than the decision tree in the out of sample evaluation. So that's why this is the main reason behind this thing. So that will be discussed in the next slide. So as per that, why did the random forest outperform a decision tree? In the sense here, the random forest algorithm, it leverages the power of multiple decision trees, and it does not mainly depend on the feature importance that given by the single decision tree. And just let's take a look at the feature importance given by the different algorithms to different features. So see the things. So here some coding is there, and after that here all the way we are getting the things. The prediction is there, and as you can clearly see in the above this graph, here the decision tree model gives a high importance to the particular set of features, but the random forest chooses the features randomly during the training process. See, actually the green color is given as a decision tree, and then another that color is given as a random forest thing. So here, random forest chooses the features randomly during the training process. Therefore, it does not depend on any specific set of features. So this is a special characteristics of the random forest over the bagging the trees. Therefore, the random forest can generalize over the data in a better manner. So this randomized feature selection makes the random forest much more accurate than a decision tree algorithm. So that's happening. That's why all the way compared to the decision tree, the random forest is somewhat better one. So that's happening here. And next thing, decision tree versus random forest. When should we use which algorithm? So that's the thing. See, already I told you the random forest is suitable for situations when we have a large data set and interpretability is not a major concern. That's a very important. So, but the decision trees are much easier to interpret and understand. Since a random forest combines multiple decision trees, it becomes more difficult to interpret. That's a very important thing. Some good news is it's not impossible to interpret a random forest. And also, the random forest has a higher training time than a single decision tree. So you should take into consideration because that is any what uh, suppose we increase the number of trees in a random forest, and the time taken to train each of them also increases. So that can often be crucial when you are working with a tight deadline in a machine learning project. But I will say the instability and dependency on a particular set of features, the decision tree are really helpful because they are easier to interpret and faster to train like that. That's why that is easy to interpret and understand. And another way, another very little knowledge of the data science can also use a decision tree to make quick data-driven decisions. That is that in that cases also, in some cases the decision tree is very useful for making the quick data-driven decisions. So that's the thing. And next one, what are the different applications, advantages and disadvantages. And whenever we are talking about what are the main advantages of using random forest versus single decision tree, in the sense in a real time, in a real world, in a real time application, we would like to reduce both bias related and variance related errors. So this issue is well addressed by random forest. So that's why the random forest is nothing more than a series of decision tree with their finding that combined into a single final output. So they are so powerful because of their capability to reduce the overfitting without massively increasing error due to this bias. So that's why the random forest, on the other hand, these are the powerful modeling tool that is far more resilient than a single decision tree. So they combine the numerous decisions to reduce the overfitting and bias related inaccuracy, and hence it produces the usable result. And what are the advantages to using the decision tree lesson? First one is very easy to interpret and make the mainly for visualization purpose, and and internal workings are somewhat capable of being observed, and thus it make it possible to reproduce the work. And it also handles both numerical and categorical data, and it performs well on the large data sets, and extremely it's a fast one. And what are the disadvantages of decision tree in the sense here? Building the decision tree requires the algorithm is capable of determining an optimal choice at each node. One popular algorithm is the Hunt's algorithm. Actually, that thing, the one popular algorithm is the Hunt's algorithm. This Hunt's algorithm is a greedy model, the meaning that it makes the most optimal decision at each step, but does not take into account the global optimum. So, what does it mean? In the sense, it's nothing but at each step, the algorithm chooses the best result. However, choosing the best result of a given step does not ensure you will be headed down the route that will lead to the optimal decision when you make it to the final node of the tree. That is what is a leaf node like that. And second disadvantage is these are decision trees are prone to overfitting, as I already told you, especially when a tree is particularly deep. So in that case, this due to the amount of specificity, the property specificity, we look at leading to smaller sample of events that meet the previous assumption. So this small sample would lead to unsound conclusions. An example of this would be predicting if Boston that some game-oriented application we are using. So that is a thing is happening. So there is a disadvantages of decision tree. So what are the advantages and disadvantages of random forest? So the advantages of that random forest is it's a powerful and highly accurate, and no need to normalizing. It can handle the several features at once and run trees in the parallel way. Disadvantage sometimes it's a bias to certain features sometimes, and somewhat slow process, and it cannot be used for any kind of linear methods, and it's worse for high dimensional data. So these are some of the disadvantages, and we'll go with some live demo how will that both random forest and this algorithm is working. Okay. Is visible? Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. So here, actually, in this case, just we are combining decision tree and random forest. How it will be working? So first we'll go with this. Will be actually begin with just importing all the library. That is the what are the things to be needed. So first we are yeah. So go with that. And the next thing we are motivating for the random forest decision tree. Decision tree. In this case here we are creating decision tree. So just to consider following two-dimensional data, which has one of the four case labeled. So in that case, we are going to create a decision tree. See here the centers are yeah. Here are the different 7, 1, 2, 3, 4, 5, 6, 7. But here I'm making that center into some 5 or like that. Yeah, so the different 5 categories are 5 categories. The center should be in terms of the 5. So the 5 things are categorized, and after that we'll go with that fitting up the decisions. So then we get the visualized output for the classifier. So we get based on the previously we are making what 7. So here that will be converted into 5 classifications. So this is the simplest way of that classification. So all the way it's happening, and finally we are. And next one is the based on the decision tree and the overfitting. So this is the overview of.
Sir, can you just repeat this experiment, please?
What?
Can you just repeat this experiment, please?
I can't get you.
Can you just repeat this experiment I just did, sir?
Just a minute. So once I will finish, then once finished, then we just will ask the question. And finally, actually, just I'm concluding my session. Here, the decision trees are very easy as compared to the random forest. But the decision tree just combines some decisions, whereas the random forest combines several decision trees. So that's why it's a long process. It's slow, whereas the decision tree is fast and somewhat it's operate easily on the large data sets, especially the linear one or linear model. The random forest model, it needs somewhat rigorous training. When you are trying to put up a project, you might need more than one model for that. So that's a large number of random forests more than a time. So it depends on your requirement only. So if you have less time to work on a model, you are bound to choose a decision tree. However, the stability and the reliability predictions are in the basket of that random forest algorithm. So that's the thing. This is the overview of the today's session. Thank you so much. So any questions?
Participants, can I ask your doubts to a resource person now?
Yeah. So
Sir, can you show the slide number 22 where you have differentiated these two algorithms?
yes.
22.
Slide number 20.
22, sir.
Yeah. Yeah, is it visible?
Yes, sir. Yes, sir. This one. When to use which that only I missed. Sir, yes, sir. This one. So, yeah. Okay, sir. Thank you.
Sir,
Yes.
Sir,
Yes.
sir, random forest also will consist of number of decision trees, no, sir?
Yeah, yes, exactly.
Okay, sir.
Hello, can you hear me, sir? This is Bharti.
Yes, ma'am.
Sir, upon what is the basis on which you choose the different model, this different ways in which you can do?
What, ma'am? I can't get you,
What
ma'am.
is the basis on which you choose whether you have to take a random forest or your decision tree or logistic regression?
Yeah, that's already I told you. In that, based on our, I see. Suppose if you go for the accuracy and other things, we go with that this algorithm, decision tree algorithm.
Forest.
Yeah, that the random forest is better. See, that is
Yeah.
the thing. Why? Because the random forest model needs some sort of rigorous training is needed. But somewhat
Okay.
we get the accuracy by somewhat easily we can get the accuracy. But even though the training, more training to be needed. So in that cases, whenever the data set is actually decision trees algorithm is somewhat fast, and also yeah, this decision tree algorithm is very useful for the large data sets, especially
Okay.
whenever we are choosing a linear model, linear one. So in that cases, we go with the decision tree.
Okay, so the relationship between the dependent and independent variable does not is not taken into consideration where you when you decide upon what kind of method we are going to use. or it
Yeah,
is
that's the
only
thing.
based on accuracy and the time required?
Yeah, that's the thing. See, suppose if you go for any medical-oriented application, in that case, accuracy
Yes.
is somewhat very important. See, even
Correct,
though
correct.
the complexity wise, it's somewhat complex system, but even the accuracy is very important. So in that case,
Okay.
we can choose such kind of model. So that's the thing. So based on our application, that's why in the loan application, either both the decision tree and random forest, but even though both are relatively same, but whenever we are large kind of data sets, in that cases we'll go with that random forest or like that. So that's the thing. So that's happening. So based on that, you can choose it.
Okay. If the dependency is based on more number of variables and if you require accuracy, you should go for random forest.
Random, yes, exactly, yes.
Okay, okay, okay. Thank you, sir.
Yeah. And
Sir,
another
will you be
important thing,
sharing your PPT?
yeah, sure, ma'am, sure. Surely I will
Yes. Thank you
share it.
so much.
And another very
Yes, sir.
important thing, the decision tree, already told you the advantage of decision tree. The decision tree is it can handle for both the numerical and categorical data. In that cases, we'll go with the decision tree. Suppose if you
Okay,
go
sir.
any kind of classification is based on the categorical and numerical, in that case, we go with the decision tree algorithm. That is also.
Okay.
Yeah.
Okay, okay, sir. Okay.
Sir,
Sir,
is
can you
there any other metrics for like MSc artist score? Like,
There are so many metrics like confusion metrics are there. F1 actually we have seen only F1 square only we have seen in this slide. And another very important thing, gain and lift chart. That is also very important. Gain and lift chart. If you want, just make it. Otherwise, I will post it in that chat window.
okay, sir.
Gain and we may say lift chart. That is also very important in that criteria. And that
Okay, sir.
another thing, ROC, that AUC and ROC, that is also very important. And we may say log loss. Another
Okay.
important thing we may say Guinea efficient, Guinea go efficient. That also there. And root
Okay,
mean
sir.
square, we know RMS. Root mean square, normally we are using
Yes,
it.
sir.
Another very important thing, cross validation. That is a very important parameter. Why? Because it's not a metric, even though it's not a metric, but normally whenever we go for such kind of things, we have to use the cross validation features also.
Okay, sir. Thank you, sir.
Another feature also that what we may say what a concordant and discordant.
Concatenation.
No, no. What a this, concordant and discordant ratio. That is also it's somewhat new. That is
Okay, sir. So from these metrics, we can came to know that accuracy or how much efficient the model is.
yeah, yes.
Okay, sir.
See, that is each and every features, each and every evaluation metrics for very specific purpose. But normally,
Okay.
what we use precision, recall, accuracy, and F1 square only. See, normally,
Yes, sir.
whenever we go for any kind of research, normally we consider only these 4-5 parameters, 4-5 metrics only, like precision, recall, accuracy. So based on these three only, we are finding the F1 score like that. But apart from that, some more parameters are there. So these are some of the parameters. That is the
Okay,
evaluation
sir.
metrics.
Okay, sir.
Sir, can you share the that collab site
What, ma'am?
that
What?
the collab site that you have shown?
Yeah. I will share. Yeah, I will share it. Actually, I will share the PPT to organizing committee. Then they will share in that PPT itself. We are having that collab. Okay, that we will take it.
The PPT will be having with the reference with that collab site, na, sir?
Yeah.
Okay.
Otherwise, I will share it in the chat window now.
Yeah, sir.
Any other doubt from participant side?
Just a minute, ma'am.
Sir,
Just a minute.
sir,
Yes, please.
sir, how to print the model in mathematical form?
How to?
Print that model in mathematical form. we'll get the output, no, actually.
That you are asking about visualization of that model, is it so?
Yes, sir. Yes, sir.
Yeah,
Visualization of
for that also the coding is there.
So-
Suppose if you go for making that thing, you can actually even in that collab link also that actually I'm making all the comparisons based on that only. So that is also there. But the visualization methods that even the Python itself we are having visualization methods. Based on that, easily we can visualize. Easily we can make that visualized effect.